All right, this is number 23 on section 8.8 for Algebra 1, and we are supposed to find the vertex and the axis of symmetry, and then pick about 4 other points and graph this equation. Now, we know this is a parabola because we see the square as an exponent. So it's a parabola. Anytime the biggest exponent is a square, that's what you're going to have, that U-shaped curve. If there were a negative out front, this curve would open down. But there's not, so this is a curve that's going to open up, and so we know the vertex will be right here, and that vertex would actually be the minimum value of the function, the smallest y we could get. All right, so let's start this. One of the things that we could do here is go ahead and label ax squared plus bx plus c. If you're not labeling and you don't know where to start, that's the problem, because you've got to be able to find your A, B, and C to get started. Now remember, if a term is missing, like let's say I've only got my square term here, so if my x term is missing, I can put a 0 in front of the x, because 0 times x is 0, and normally we wouldn't write that down. And then the constant term, the number on the end is missing, so I could write a 0 for it too. And now I can tell you what my A and my B and my C are. You should always do this because your formulas call for A, B, and C. So if you're having trouble getting started, label it and write down your A, B, and C. That's the first step to fixing getting stuck, okay? Well, the A here is a half. The B here, we filled it in. It was 0. Sometimes missing numbers are 0 if they're not there at all, but if you just have an x, remember the missing number would be 1. Here it's 0 because we didn't have that term. I had to add it in. The number on the end was missing and we added in a 0, so here's our A, B, and C. Why did I care about that? Well, if you remember, the vertex and the axis of symmetry, we use this same equation to find them. It's a 2-for-1 equation, and it is the x is equal to negative b over 2a. It's that very first part of the quadratic formula that we always see. Okay, if I've labeled all this, I get negative b. Well, b is 0. If b is 0, I don't even need to plug in the denominator because 0 over anything is just 0. So remember, that's the formula that tells me the x-coordinate of the vertex. It also tells me the axis of symmetry because the axis of symmetry goes through the vertex. Okay, so I can go ahead and graph my vertex. I got one other little step to do, but while I'm drawing my axis here, this is my x-axis. I'm going to get some other points in a minute. Just going to get some things in here first. Okay, now, if you notice, if I go to graph my vertex, I'm missing the y value. Do you remember how you find the y value? You find it by taking that x and plugging it into the equation. Well, if x is 0, I actually listed it over here just so I could write it down here. If x is 0, a half times 0 squared. I'm just plugging in 0 into the equation up here. I'm circling it in yellow. Remember, this was my original equation. A half times 0 squared is just a half times 0, which is 0. Okay, so that point is 0, 0. When I plug in x is 0, I get y is 0. That's my vertex. So let me go graph it. I'll graph in black. All right, so I know my axis of symmetry is a vertical line through that. That's what x equals 0 means, a vertical line through 0, which is the vertex. It's always through the vertex. So I know I'm going to have mirror image things here going on. Now all I have to do is plug in these points. If you have a graphing calculator, the cool thing about it is you can go to the y equal button and you can type in 1 divided by 2 for 1/2, hit your x button, and then hit the square button, and then you've got the equation in. So then you go second, what is that, graph. Above the graph button, you'll see the table button. It'll show you the table, and you can pull values off. Now, I chose even values here because I'm going to square the number and then multiply by 1/2. So I just kind of wanted some even numbers because I don't like graphing fractions. If you put this in the graphing calculator, one thing you can do is pick nice whole numbers to graph, but you always need some on both sides of your vertex. So it helps to find your vertex first, and you need some to the left of it and some to the right of it. All right, if I plug in -4, a half times -4 squared, -4 squared would be 16, and a half of 16 is 8. If I plug in x is negative 2, I'm doing this without a calculator, but you could do it with a calculator. You could use a normal calculator. You're just going to have to do a bunch of button punching, okay? Negative 2 squared is 4. Half of 4 is 2. If I plug in 2, 2 squared is 4. Half of 4 is still 2. And then if I plug in 4, 4 squared is 16. Half of 16 is 8. Just plugging it into that equation that I circled in yellow. I'm just doing it quickly because that one's not a hard one to do quickly. So let's go graph our points. At negative 4, 1, 2, 3, negative 4, I'm supposed to be up at 8. 1, 2, 3, 4, 5, 6, 7, 8. Now, my graph doesn't go up that high, so I'm just going to draw the point in. Now, notice that at 4, I'm also up at 8. I could have known that just by saying if I go this much over on this side, I'm going to go the same amount. I'm going to count the same amount over on the other side of wherever the axis of symmetry is. That little black line I drew shouldn't be there. It just picked up when I was moving my cursor. If I plot x is negative 2, y is 2, that would be here. I already had 0 plotted because it happened to be the vertex. I actually wrote it there. Also, it didn't have to. Could have just put it up at the top. If I'm at 2, it's also 2. And again, if I were this much over to the left of the axis of symmetry, I could have known that I'd be that much over on the right. That's a good enough thing for us to draw in our parabola, and that there's a sketch of the parabola, okay? So this is how you do it. This was an easy one because we had a lot of the numbers fall out, so the math wasn't as hard. Let's do it. Okay, so we're going to do 25 now. The equation is y equal x squared minus 4x. Okay? All right, so I'm going to label my equation first. That might be the first step you do. Step 1, label your equation, if you like steps. If I write steps down, I'm probably not going to have room to do it on this page, so you're going to have to be writing as you go if you're watching this. Label equation and write A, B, C. That's going to be step 1, okay? I'll just put steps here. Okay, so I'm going to label it. I'm going to label it in a different color. I'm going to do purple or something. So it's ax squared plus bx plus c. So if you notice, I'm missing the number on the end, so I'll put plus 0. Okay. So a is 1. It's the invisible 1. B is negative 4. I have to take the sign with the number. So I've got to write down negative 4, not 4. If you write down 4, you're not going to have the right parabola graphed. C, I actually added that number on the end. If it's missing, I can put plus 0. Why did I do that? Because in step 2, I'm going to find the vertex and the axis of symmetry. And the reason I put them on one step is it's the same formula. I'm going to put the axis of, I'll just put S for symmetry. The equation is x equal negative b over 2a. Okay? So now I'm going to write x equal negative b over 2a. And my b term, I've written it down here, negative b. Notice I'm using a parentheses to plug in b because there is a negative in front of b, and b is negative. If you don't use a parentheses, make sure you're careful because that's where most people mess up. So I'm just telling you, you can avoid it if you'll put a negative in parentheses. What I always do, what I tell students to do if they continually keep messing that up, is everywhere you see a variable, put a parentheses so you can stick it in. That way you make sure you write the negative down and all the other things you need. Here, a was just 1. On top, a negative negative 4 is a positive 4, and on bottom, 2 times 1 is 2. So my x is 2. All right, what does that tell me? It tells me my axis of symmetry is x equal 2. It's a vertical line through 2, and it tells me my vertex has an x value of 2. Now, if I want the y value, there's 2 things I can do. I can plug this in by hand. So I'm going to make a little place to plug in values here. Since my vertex is 2, I'm going to make sure I plug in, I'm going to put the 2 here. I'm going to plug in 2 numbers to the left of it and 2 numbers to the right. I'm going to choose negative 1 and 0, and then I'm going to choose 3 and 4. Okay, so I'm just choosing some random numbers here around it, and I'm hoping I get nice, pretty values out of this. I should, because I don't have any fractions in this one. Now to get the vertexes, which I want to start with, remember that was x is 2. So let's plug it in. Again, you could type this in your calculator, and you could type in, if you have a graphing calculator, on the y equal x squared minus 4x. And hit second graph, which is the table, and you'll get all these for you. You don't have to plug this in by hand, and people hate that, so it's a great way to save work. All right, if you plug it in, 2 squared is 4. Minus 4 times 2 is 8. 4 minus 8 is negative 4. So my vertex is 2, negative 4. I'm going to graph that here in a minute. Let me go ahead and put these marks in on my coordinate plane. That's one of the reasons I like to give you guys the graph paper so you don't have to take the time to do that. Okay, so 2, negative 4 would be here. Now, I know this graph is going to open up because if I look at the A value, it was a positive number. If it had been a negative number, it would have been an upside down U, like I'll draw it here. See if I can get it to pick up. But mine is a positive value, so I know it's going to open up. A negative A value always causes the parabola to flip upside down. Okay, this is called a reflection. All right, so let's plug in some other numbers. If I take negative 1 and square it, I get 1. 1 minus 4 times negative 1 would be 1 plus 4, which would be 5. So at negative 1, I'm up at 5. 1, 2, 3, 4. 1, 2, 3, 4, 5. Negative 1, 5. And you know what? I'm going to draw my axis of symmetry in because if I'm this far over on this side, I'll be the same amount over on the other. If you were using good graph paper, you would actually count it. I'm just kind of estimating it since I can't guarantee my marks are equally spaced. Okay, if I plug in 0, 0 squared minus 4 times 0 is 0. So this one actually goes through the origin. And since that's 2 over from the axis of symmetry on this side, I'll have another point 2 over on the other side. If I plug in 3, 3 squared is 9. 9 minus 4 times 3 is 12, would be negative 3. So at 3, I'm at negative 3, which would be about here. And since I got a point 1 over from the axis of symmetry on the right, I can stick another one over on the across the other side of the axis of symmetry, the same distance over. And then 4. 4 squared is 16, minus 4 times 4 is 16, would be 0. 1, 2, 3. Oh, I already graphed that one, didn't I? Now, why did I already have it graphed? Because I had graphed 0, 0, and I used the axis of symmetry to graph a point the same amount over on the other side of the axis of symmetry. I sometimes call those buddy points because they're at the same y value and they're the same distance away from the axis of symmetry. I've got plenty of points here, so I can graph this, and here's my pretty nice parabola. Now we're going to do one more. No, we're not, because the time's running out on this video.